on Facebook. Number of friends we have on Facebook. And the paradoxical result is that, on average, our friends have more friends than we have. Yes, on average, our friends have more friends than we have. And there's a couple ways to look at that. The one sociological argument is that, on average, we are drawn to people that are more popular than us. This is the definition of popular. Popular is if you define it Facebook-wise, popular means they have the most likes, which probably means they're tied to more webs, if you will. They're tied to more webs. So they're, by definition, a popular person is tied to more webs, but they probably are also the largest value in that web. So anybody attached to them, most likely, since they're pulling the average up, being a large value, anybody tied to them is going to be less than that average value. That's kind of a hand-wavy way of looking at it, mathematically way of looking at it. An interesting thing that I would like to see, and I don't know if Facebook gives you this, does Facebook tell you how many friend requests you sent versus how many were sent to you? Is that collected at all? That would be interesting, I think.
That's mean data.
That's mean data?
Mean.
Mean?
Oh, cruel.
Oh, mean, oh, not mean like average. Mean like, why are you even asking that, Joe? Instagram does?
Show you like how many people are following you versus how many people
You're following. Ah, because Instagram it's not a two-way. You can follow someone without getting a response back, unless they're set to private, in which case they have to like okay you. But that would be interesting to see if there's a correlation between the number of requests you have to your number of friends. If there's that'd be two-variable analysis. Number of requests that you've had made to you versus how many friends you actually have. It'd be fun to see if they both go up. I don't know, it's a theory, as I was thinking. The problem is I can't prove the hypothesis because I counter-proved it. I made a very small Facebook with 5 members, and then I drew random lines between them, and I proved that in my little tiny Facebook world, the average number of friends is not greater than, on average, the number of friends per node. So I mean, I don't know whether the math that they showed me is a bit hand-wavy, so I'm not exactly sure I believe it yet. But I didn't come here to tell you that. Not really. I came here to talk about the problem we ran into while we were dealing with that data. So we had my Facebook friend sample data, put it in a little block, put it in RTIs, graphed it, and what do we notice about my friends on Facebook? What was the shape of that distribution? You all had beautiful ones drawn on your quizzes.
Oh yeah.
Remember what it looked like?
Yeah.
It had that, it kind of had that long tail on one side. Yeah, long tail on one side. So we calculated the average number of friends my friends had. And we calculated the standard deviation, both of which were very interesting. They were both about 470 each. And then we decided, what should we do with those numbers? Did we do anything with those numbers? We shelved them. We said, well, we got the average, we got the standard deviation. Crap, here's the data. It looks wildly skewed. So you can bust Chebyshev out, comrades. Or we looked at it a different way. And then what did we do? Once we decided we shouldn't use the average and standard deviation, what do we do? It seemed very simple, I think, comparatively. I was on the second page of the quiz. Oh, before the margin of error, thank you. Before the margin of error, what do we do? I love that, by the way. What do we apply the margin of error to? The margin of error is the standard deviation, Emily, thank you very much. But what did we plus? Good. We figured out on average what percent of my friends have more friends than I do. So I didn't care how many they had, just yes or no, do they have more than me? Because that doesn't care the shape of the distribution. It's just keeping track literally of you have more, you have less, you have more, you have more, you have less, more, less, and so forth and so on. In this way, the size of the data point doesn't matter. I'm just comparing it to my 600 and whatever it was. Is it over on this side or this side? That's it. Fair enough? Margin of error was a huge part of that. Thank you, Emily, for that. It's very important, actually. But it's a little less detailed, isn't it? Because then I can't do what Zuckerberg did, which was actually go and data mine every single person using Facebook, figure out their average number of friends, and then compare that to the average of their friends. I can't do that with that. All I can say is, on average, what percent have more than me. But I am willing to sacrifice that bit of detail in the data because the average, I think, was being pulled towards that tail that we already described. It's pulling towards that right side tail that was floating out. Now, the reason I bring this up is not because Facebook is important. It is for certain things, and it's not for a lot of things, too. But that logic actually ties to more than just Facebook. And I wanted to share one of those with you today. Let's do that. Okay? I want to share in one way how that is important with something that actually happened in my family's life. And I try to share these as much as I can because it's amazing how statistics can be misinterpreted